Good morning. We're going to continue our study of using row reduction. So at this point, we can state three equivalent statements on non-singularity. Given an n by n matrix, A, the following statements are equivalent, meaning they say the same thing. First, A is non-singular. Second, AX equals 0 has only trivial solution. And third, A is row equivalent to I. It's these two, A and C, that are particularly important for what we're doing today. Corollary to this, system AX equals n of n linear equations and n unknown, so it's got to be a square system, has unique solution if and only if A is non-singular. And so that also means, of course, that the three statements before hold. So if A row reduces to the identity matrix, the system has a unique solution. Okay, so as I said, it's really A and C that are going to be important for what we do today. A is non-singular and A is row equivalent to the identity matrix. So we can row reduce A to the identity of the appropriate size. Find the inverse of this matrix. Right, so we did a method on that already. That was the third day. Now we're going to look at a second method. Here's the method. Take your matrix, augment it with the appropriate size identity matrix. Then row reduce it. If A is non-singular, you're guaranteed to get the identity matrix now on the left-hand side. And what you'll find, and I believe I go into more detail on this on the video, is on the right-hand side, you're going to be left with the inverse. So there's our first step. Set up your augmented matrix. Right, now it's just a matter of row reducing it. So I think we'll do by hand first, and then we'll verify it using technology. What should we do first?
M1 plus M2.
You want to do anything concurrently with that?
-2R1 plus R.
And so that should zero out everything in column 1. And then what are we going to be left with? Two plus -1. -4 plus 5. One plus 0. 0 plus 1, 0 plus 0. -4 plus 7. 8 plus -3. -2 plus 0. 0 plus 0, 0 plus 1. Yes? Yes. lovely designer. Can I just... So what should we do next?
Would it be negative 3R2 plus R3?
Confident? Ah, that's a shame. It's a shame. Have more confidence.
Will do.
That's right. So that should zero out then column 2, right? Which means the first 2 rows remain unchanged. Negative 3 plus 5. Negative 3 plus negative 2. Negative 3 plus 0. And then 0 plus 1. That's what we have, yeah? Now what?
1/2 row 3.
Are we in REF?
Yes.
Right, which means that algorithm's done. We now kick into the second part. What should we do now?
Negative row 2 plus the other. Or negative row 3 plus.
And what would we do after that? We can do 2 at 1 here, right?
3 plus row 3 plus 1.
So let's get rid of those. Row 3 is going to remain the same. Negative 1 plus 1. 5 halves plus 1. Three halves plus 1. Negative a half plus 0. 1, 2. That becomes 0. Oh dear. Oh, okay, that's not too bad. Negative 10 plus 1. Negative 6 plus 0. And then 2 plus 0. Is that where we're at? Now what?
-2 row 2 plus row 1.
So it's what? -7 minus 9. -5 minus 6. And 1 plus 2. Left-hand side of that augment, it's the identity matrix. So that means this matrix was invertible. And the inverse is the right side. There's our inverse. And of course, you can always verify it by multiplying the two matrices together. Right, multiply that matrix and the original matrix and verify you get the identity. I'm going to try two different ways. I'm going to start with the one that we went over last time. I'm just going to row reduce and then put in the matrix. Right? Remember matrices? The entire matrix is in braces, and then each row is in braces. Was that what we got? Excellent. Now I'm going to see if this works. Although I don't think it's going to. Now that I look at it, it probably won't. That's not what I wanted. This is what I was thinking of. Oops. But I don't think it's going to work. No, didn't think it would. What if then I remove these? No. If I remove these? No. Okay. Bummer. I was hoping that would work.
Do they have a function for our inverse?
You can, yeah. I think it's inverse of A. It's fun. I was really hoping I could augment two matrices together. I'll see if there's a way to do it, but it's not showing up in the documentation center. But anyway, this command here, identity matrix, is just the identity matrix of whatever side you put in. All right, so if I do 10 by 10 identity matrix. I was hoping that would work. Oh well. Again, we'll do it by hand and then verify it. To start by forming your augmented matrix. First step.
Negative R1 plus R2. And negative 3 R1 plus R2.
That would become 0. 2, right? And 3. And then negative 1, 1, 0. then 5, 6 there, and then of course this will just be -3, 0, 1. Is that what we got? What do you want to do now? See if I can.
1/2 right there.
Yeah, unfortunately, we're gonna have to put a fraction in right away. Ah, it sucks. Then what?
-5 raised to +4.
I'm gonna ignore that for now. 3 for that 1, 0, 0. So when I rewrite these. So we get 0, 0. -15 halves plus 6. Would be what?
27 halves.
-15 halves plus 6. I think you did 15 halves plus 6. I saw your hand next.
-3.
-3 halves. Then it's what? 5 halves minus 3?
One half. 8.
1/2?
Sorry. -11 halves? Wait.
So 5 halves minus 3.
-1/2.
-1/2. Know what I said? Arithmetic is hard. I hate arithmetic. -1/2. Then it's what? Oh, this one's nice. -5 halves. And then 1. Now what are we going to have to do? Also going to, just so I can have everything kind of centered. Move you to there. Because this is not REF yet.
Root 3 by negative 2/3.
Oh joy. Multiply all of row 3 by negative 2/3. One, negative a half. So what is negative a half times negative 2/3?
Negative 2/6.
What is it?
2/6.
Reduce that.
Oh, 1/3.
And you caught the negative and got rid of it. 0, a half. Negative 5/2 times negative 2/3.
Negative 10/6. Or you want to say it's positive 5/3.
Positive 5/3. Of course, times 1. That's an easy one. So this is where we're at right now. Now what?
Negative 3/2 row 3 plus row 2.
I agree. And then what?
Row 3 plus row 1.
What is it?
4 row 3 plus row 1.
And so 1, 0, 0. Three, 1, 0. The first two columns should be unaffected. Now let's work our way up. So that's 1. Those should both be zeros. One third. Negative 3/2 times a third. Negative 1/2. Minus a half. Negative 1. 4 times a third. That's easy, thankfully. Plus 1. So 4/3 plus 1. 7/3. 5/3 times negative 3/2 would be negative 5/2, right? Plus a half. Negative 2. And then 20/3 plus 0. Then negative 3/2 times negative 2/3. Oh, that one's nice. Plus 0. 4 times negative 2/3. Negative 8/3 plus 0. So that's where we're at right now. What's next?
-3 root 2.
First column will remain unaffected. Second column becomes that, and third column remains unaffected. Work our way up. So what is it? -1 times -3? 3 plus 7/3. 16/3. -3 times 1/2. -3 halves. -3 halves plus 20/3. So that's the same as what? -3 halves is -9/6. 20/3 is 46.
Or is it now?
I do get 1/2, but she would still be the 5/6. We never changed it.
Because I looked at the wrong matrix. Yeah, that should be -2. Been looking at the wrong freaking matrix. Okay, there's that. That's right. Okay, well, this is going to make it easier then. 6 plus 20/3. Let's actually look at the right one this time. -2/3, 1, and then -3 minus 8/3.
-17/3.
Do we have the identity matrix? Then this matrix is non-singular. And B inverse is that right-hand side. That was a pain. I just clicked the wrong button. Okay, so we'll close you out. There we go. Was that what we got for the row reduction? Good. That means we did the math right. Before we get started, do you think this matrix is non-singular or singular?
Singular.
Why?
The full column of
Yeah.
zeros.
This matrix will wind up being singular. You're not going to be able to reduce this down to the identity matrix because of that column of zeros. Let's verify it. You know what? I'm not even going to bother augmenting. I'm just going to start reducing the matrix. So we do what? -3 row 1 plus row 2. Oh, wait, no. Let's switch two matrices. Which rows do we want to switch? 1 and 2 or 1 and 4? Or do I even want to bother switching? I mean, I already have that row. I already have all those zeros there. That'll probably be the best bet, wouldn't it? It'll be -1 for row 2, -2 for row 3, and then -1 for row 4, right? One, 0, 0, 0. And because everything else in row 1 is a 0, nothing else changes. So here's the question. Do I want to multiply row 2 by -1/2? Or do I just want to use that -2 to zero out everything below it? Everything else in row 2 is 0, so it doesn't matter in terms of the arithmetic. Oops. And then row 3 plus row 4. And then I can stop. Row of zeros means there's no way we're getting the identity matrix out of this. So C is not row equivalent to I4. Which means C is singular, and we're done. So find the inverse. I mean, again, they were nice. I essentially did half the work for you by making it lower triangular. Looking at this, do you think D is non-singular? You think it's singular?
Yeah.
You don't think that's going to row reduce down to identity?
Yeah, beautify.
That's going to have to. Right? You're not going to get that last 3 to be 0. So this is going to be non-singular. And we're going to say that there's no instructions that says we can't use technology. So we're going to use row reduce. What is the first row that I should enter?
-1, 0, 0, 0, 1, 0, 0, 0.
Second row.
2, -2, 0, 0, 0, 1, 0, 0.
Third row.
3, 1, 8, 2, 0, 0, 0, 1, 0.
Fourth row.
1, 8, 3, 3, 0, 0, 0, 1.
So there's your output. And so here's what I'm going to do. Actually, you know what? I think I'm just going to do this on a new slide. So that is what we wound up getting. So was this matrix non-singular? Is it invertible?
Yep.
And what is its inverse? And tell me if you're going to go rows or columns.
Column -1, -1, -2, 2, 0, -1/2, -1/4, 12, 0, 0, -1/2, 1/2, 0, 0, 0, 1/3.
We in agreement? So this method, much more efficient than what we went over before. Okay. Oh. First quiz is now available. Oh wait, no, it's not. Let's fix that. I would lock till 12:15. Let's try that again. Quiz 1 is now available. I've never actually seen this as a student, so this is a new look for me. At least they show the instructions, that's nice. It is timed. You have 90 minutes, one sitting. It'll be due February 11th. That's next Tuesday. That's Tuesday before class starts. Open resource, you can use whatever you want. Just can't obviously Google the answer. I want to see your work. There's a mixture of questions. Multiple choice, fill in the blank, numerical response, and file uploads. For file upload questions, you'll do your work on loose leaf paper in pencil black ink only. I won't accept anything else. Make sure it is written neatly. I can get rid of that clearly label. Make sure it's written neatly, legibly, large enough that I can read it. If I can't read it or understand it, I'm not going to grade it. You'll upload that file to that question. So you're only going to upload the work for that one question. You can do it as either an image or a PDF. I recommend PDF. I think it limits you to only one file upload. Can't recall if that's Canvas or Blackboard that does that. But try to keep it to one file. Obviously, show all of your work. I will award partial credit on the file response questions at my discretion. So I have to be convinced that you know what you're doing. I will not accept any files sent any other way. Email, message, whatever. It has to be uploaded. Before you start the quiz, I would recommend that, of course, you take care of any business you have to before opening it. Timer starts as soon as you hit take the quiz. Also, make sure that you're in a location with a stable internet connection. Because if your connection drops, you're not going to be able to re-enter the quiz. I've had that happen.
My neighborhood had a blackout a few days ago.
They won't let you back into the quiz if you leave. And I don't recall if it automatically submits or not when time's up. I think it does. So make sure you have a stable internet connection. There's nothing worse than, halfway through decides to drop out on you. If that does wind up happening, let me know as soon as possible. I can reset it. Problem is that means you have to start all over. Right, because it'll delete all of your work. Does say there's 11 questions worth a total of 50 points. Now I'm curious, what happens if I say take quiz? Oh, cool. Okay, so you will see a countdown there. That's nice. I've never actually done this, so. Right, so as you can see, here's the first question, and it's a file upload. And so you just choose a file, double click.
That's it.
Yeah.
Oh, last quiz. The last quiz, you had to type out the answer, then upload the file, right?
Yeah, I decided not to do essays this semester.
Are all of them file upload? Or just some?
I don't think it's all of them. The vast majority of them are.
And uploading the file is part of the time we have.
Yes. So not all of them are file upload. Here's one that's not.
So I can use my tablet to like upload the file as like basically.
I don't know if it's going to let you on to the quiz in 2 devices, so you'd actually have to take the quiz on your tablet. Or use your tablet to take a picture and upload it to like a cloud. Right, but 90 minutes is more than enough time to account for doing the work as well as uploading the files.
So the standard is just take a picture of the page.
Right. I recommend doing PDF. So get like a PDF scan app and use that to convert as a PDF. Because with images, like I said, there's only one file. So if you're on multiple pages, it'd be better just to do it as a PDF with multiple pages, because that's a single file. Right, so obviously for non-file uploads, there's no partial credit. So that's why for the most part, I do try to keep the vast majority of them as file uploads, but there will be some that aren't, and you won't get partial credit for those. So I think I counted, what, 3 that weren't file uploads? So the rest are. And again, that 90 minutes should be more than enough time. I generally try to figure 1 minute per point. So using that logic, that should leave you with 40 minutes to get all your files uploaded and check your work. Any questions? Excellent. Have a good weekend. Good luck on the first quiz. See you on Tuesday.